Okay, so may I ask you, what have you learned yesterday? Yesterday session. Anyone? What have you learned of yesterday session? Do you still remember?
Yes,
Manometer.
doctor.
Okay, can you
Manometer.
manometer, and then
Learn
Barometer.
about derivative of
derivations of
hydrostatic fluid.
hydrostatic equation.
Hydrostatic equation.
Okay, the last class we learned three main things. The first, hydrostatic equation. Second one, barometric. And last one is manometer. Okay, so for today's session, I'm going to show you how to derive the fundamental parts of manometer. So what is manometer? Manometer is the pressure instrument used to measure the pressure that use column of liquid to measure the pressure. Alright, so when we look at the manometer, we have the column, and second one we have the different shape. For this case, it is the U-tube shape. Normally, manometer adopt the U-tube shape. Alright, on how to measure the pressure. Why we use the U-tube shape? Because by using the U-tube shape, scientists or researchers able to measure the specific height, the difference in height. Alright, if you use a different kind of shape, it's very difficult to measure the difference in height, as you can see in this figure. Alright, so the last class I show you the derivations of manometer. Okay, let me open the pen tool first. Okay. Right. Wait, yeah. Okay, I really hope that everyone has already joined this group. Okay. Right. So the last okay. All right, the last session we learned of the column. Do you still remember? Okay, how to derive the sets of equation from the column? Okay, before we start, I would like to ask you, what is the hydrostatic equation? Hydrostatic equation. What is it?
P2 minus P1
P2 minus P1
equals negative specific
negative
height,
Specific weight.
specific weight,
rho G
Z2 minus Z1.
Z2 minus Z1. Alright, this is the sets of equation. Very important. You need to memorize. This is important. You need to memorize this. Alright, when you deal with manometer, barometer, or any kinds of pressure instrument, this is compulsory to remember. Alright, this is hydrostatic equation. Alright, so P2 is the final point of pressure, and P1 is the initial point of pressure. So Z2 will be the same with this one. The first term, this is the first term. Alright, so just imagine this is just a simplification of manometer. I believe this is the manometer. Okay. Alright. Manometer, this is the manometer. Let's say we take only small portion of this. Okay. This is the small portion. Alright. This is the column. Right. This is the column. Okay. Inside the column, we have different kinds of fluid. Alright. This is just a revision. Okay. So what we have fluid A, fluid B, fluid C, and fluid D. And then we have the position, which is Z1. This is P1, Z2, P2, and so on. If you have any question, feel free to let me know.
Betul, saya lupa kenapa dia ada different fluid every level.
Because different fluid will have different property, such as density, gamma, different. So, for example, this is oil, this is water. Do you think oil and water will mix together?
No.
Okay, and then this is the grease. So different oil or different fluid will have different property. Once you combine together, it won't mix together. It will be separate layer. Do you understand? This is the nature.
Oh, yeah.
Okay.
So dia memang dalam manometer tu dia letak different type of fluid.
Yes, correct. That is why we call a manometer. We put different kind of fluid.
Oh, I see.
Okay. So just imagine we have different kind of fluid here. Alright. This is just a representation. Okay. Sometimes we have different kind of fluid. This is this fluid. Up until here. This fluid. This fluid. This fluid. Alright. For this case, I try to simplify. Okay. So this is my rule. We start from the from the top to the bottom. Okay. So for this case, okay, so we use again, this is the final, this is initial point. All right, so we start from P1, go to P2. So P2 minus P1 equal to negative rho A, because we go through liquid A, that is why rho A. G, Z2 again, the same here, Z2 minus Z1. And we jump to P2, go to P3. So P3, the final minus initial, yeah? P3 minus P2 equal to negative rho B. Do you still remember, everyone? The last class?
Yes, doctor.
Okay. So again, P4 minus P3, negative rho of CG, Z4 minus Z3, and finally, you need to focus on this part, because this part is critical. Believe me. When you go to the other example, you're going to use this theory. So P5 minus P4 equal to negative rho D G Z5 minus Z4. So you try to make equation. You make like this and then plus. You plus all this. For example, P2. Right. For example, I try to plus this one first. P2 minus P1 plus P3 minus P2. So what do you think cancel? Which part cancel off?
P2.
P2.
P2 and P2. So from here, you can simplify P2 with P2, P3 with P3, P4 with P4. What left here?
P5 minus P1.
Yes, correct. You must take the positive first. P5 minus P1 equal to this one. You cannot simplify, because why? Because you have different kind of fluid. A density A, B, C, and D. For this case, you have the same P2 with P2. So you try to plus everything here. So you try to plus negative rho A G Z2 minus Z1 plus minus rho B G Z3 minus Z2 minus rho C G Z4 minus Z3 and finally rho D G Z5 minus Z4. That is the final equation. Is it easy for you to remember? The step by step?
Yes, doctor.
Yeah,
It's very easy, right? Okay.
Yes, doctor.
Once you understand and know this is easy, why don't we try to use this kind of concept apply to one example. Okay, so far you guys understand the concept?
yes, doctor.
Yes, doctor.
Yes.
Okay.
Yes.
Okay, so now we have the example that we're going to try. Alright, so this is example manometer to measure the gauge pressure P1 relative to the atmospheric pressure. So the question asks, find the gauge pressure. Find the gauge pressure of A. Okay, I try to add one things here. Okay, the question asks, okay, find P A gauge. Okay, so how to find the P gauge of A at point A? So before that, what is gauge?
Pressure.
Is the unit of pressure. So what is
Pressure.
gauge? What is a gauge?
It's a device to measure local pressure.
Local pressure. So, all right. Okay. So that is correct. Remember, the first class, I taught you the gauge pressure. The gauge pressure is this. This is the pressure, and this is the first. Of course, we have the atmospheric pressure. This is P ATM. So on top of P ATM, we have P. What we call this P what? On top of P ATM, we have P.
Gauge.
P total.
We have the P gauge. Alright. So the P gauge is actually the pressure above the atmospheric pressure. Okay, so now you understand what is P gauge. Okay, so what is P absolute? P absolute is the from the bottom to the top until P gauge we call P absolute. Alright, this is P absolute. Alright, so the question asks what is the P gauge of point A? So the first step, what we're going to do here is, okay, this is our manometer. Our manometer is exposed to, can you see here? Exposed to?
Atmosphere.
Atmosphere, PATM. Okay, we label
Atmosphere
PATM.
pressure.
Atmospheric pressure. Do you think atmospheric pressure will exert force here?
Yes.
Yeah, so the atmospheric pressure will exert the static force throughout the body. Okay. And then here we have the, okay, let's say we have, this is, okay, let's say this is the P of A. All right. And then we have, this is 0.1. All right. Okay, the first is point A. This is pressure at point A. And then this is at point 1. Alright, this is the fluid. We don't know whether it is liquid or air. Just name as a fluid A. So let's say this is PA, the pressure due to point A. And this is point 1, the pressure acting in this direction. And then we jump across to this section. Okay, this is point 2. Why do I need to care with this kind of column at the bottom column? Do I need to care?
No,
No.
Okay, why?
because it's below the reference. We don't use it.
Because because the pressure the same with the elevation. So pressure 1, do you think pressure 1 same with pressure 2?
Yes. Same.
So
Yes,
when the pressure the same with point 1 and point 2, we can ignore at the bottom side. Do you get it? Understand?
Yes, doctor.
Okay. And then we jump across to this point because we have the pressure at point atmosphere.
atmosphere.
I label as a P3. Okay. So the best part, we're going to use the hydrostatic equation. So we start from, we start from the left. We start like this. All right. So first, we have to write our hydrostatic equation, which is P2 minus P1 equal to negative rho G Z2 minus Z1. All right. So remember that Z is the elevation. So what do you know about Z, everyone? Is the Z is a scalar or vector quantity?
Z is a scalar.
A scalar. Are you sure the scalar? Because the yesterday class I already mentioned what is Z. Z is a distance or displacement.
Displacement, doctor.
Okay, remember that the Z we use here, Shafiq, and every one of you here is displacement, having the magnitude and direction. So magnitude is number, direction is the positive or negative side. So when we use this as a displacement, we must confirm first the reference point. So let's say this is our reference point. At point A is our reference point. We make it like this. Okay, everyone? This is our datum, our reference, where we start our Z equal to, what do you think here? Z equal to?
0.
0.
0.
Alright, so again, okay, so we start from PA going to P1. So P1 minus PA or PA minus P1?
P1 minus PA.
Yes. P1, this is final. We're going to from A to point 1. You can see this is final and this is initial. Final minus initial. So 1.1 minus point A equal to negative rho of what? Rho of A or rho of point 1?
Rho of A.
Okay, rho of A. Because we're going through these fluids. Z1 minus Z. And then let's say this is rho of 2. Okay. And after point 1, you can see we go, after we end at point 1, we jump across to point 2. We don't care at all of this column. Alright. So at point 2 to point 3. So which one? 3 minus 2 or 2 minus 3?
3 minus 2.
Yes. P3 minus P2 equal to negative rho of 2 Okay, because we deal with the rule of 2. G Z3 minus Z2. So, what we need to do next is make it like this and plus everything. So, remember that point 1 and point 2 are the same. So, I can say this is equivalent to point 1. Okay, everyone?
Okay, Doctor.
So, can I replace here with 1? So, P1, I plus here, P1 minus P1. Can we cancel off this one?
Yes. P1 and P1.
Yes, we can cancel P1 with P1. So, what we left here is actually P3 minus PA equal to negative, alright, rho A G Z1 minus ZA, okay, negative rho 2G Z3 minus Z2. Alright. So Z1 can alright, Z1 ZA. Okay. Alright, ZA actually we can simplify into 0. Because can we see we start our datum at point A, it is 0.
Doctor.
So any question?
Oh, no.
Doctor, can I know why 0?
Which one? 0 ZA.
Yeah.
Okay, can you see this is ZA? At point
Yes.
A, we set first our datum, our reference value. This is our reference.
Got it.
When we set our reference, it is 0 already. Okay?
Okay.
Alright. So for this case, P3, what is P3? Pressure at point 3.
PM.
Pressure due to PATM. Okay? So for this case, P3 is PATM minus PA equal to the same thing here. Okay? Alright. So PATM. Once we set as the gauge pressure, what do you think of PATM?
Apa? What, Doctor?
Okay, once we set, the question asks, find the gauge pressure at point A. So it is the gauge. So what do you think of PATM?
0
Okay, why 0?
because PATM above, P gauge above PATM.
Okay, actually it is correct. 0. Why 0? Can you see this figure?
Yes.
Okay, where is P gauge? This is P gauge, right?
Yes.
Once the question asks, find the P gauge, automatically our reference point start from PATM or start from here?
PATM.
Yes. Once the question asks the P gauge, our reference value start from PATM.
Oh.
So once we set as the PATM, this PATM we know already, we cancel to be 0. Okay, remember this is our datum. Okay, once we set the PATM as our datum, we consider PATM as equal to 0. It is the same like this. Once we set this as the datum, we know already the elevation equal to 0. Once we set this above the PATM as the reference, so this is our datum or reference value, the PATM equal to 0. Everyone, do you get it?
Yes. Tapi kan Doktor, boleh tak kalau macam contohlah kalau kita nak cari P gauge tapi reference still from dekat reference yang sama, yang absolute reference, boleh ke?
Okay, that is a vacuum.
Oh.
Kalau vacuum lain. Vacuum below the PATM.
Below the, oh.
This is vacuum section. Okay, this is PATM. This is the P gauge. This is what we call P gauge equivalent to P vacuum. It is above the atmospheric pressure. So it is vacuum. Okay. Alright, so now you understand?
Yes, betul.
Okay. So now our reference, this is the ordinary case. Alright. So for this case, the P gauge is the reference is PATM. That means the PATM equal to 0. So now can we get the PA?
Yes.
We will get negative P A equal to the same thing, right? So how to, okay, negative, we go to the other side, become PA equal to positive. All right. Okay, so now everyone understand? Are you okay so far?
Yes, doctor.
Okay, this is without the value. Why don't we try with the value? All right. So far, do you have any question?
Doctor,
Yes.
in this example, Z1 will be a negative value.
The Z1, yes, perfect, negative value.
Oh, okay.
Once we go through example, and then you will find out that the Z1, Z2 might be positive, might be negative. Okay, so this is the concept we apply first. Okay, so this is the question. Okay, can you try first, everyone? I give you 10 minutes. Can you try this question first?
Okay, doctor.
Okay. For those completed, please comment you have completed. Okay. Let me read for you. A closed tank contains air and oil. The specific gravity of oil 0.9 as shown. A U-tube manometer containing mercury having the specific gravity 13.6 is connected to the tank as shown here. Column height are H1 given, H2 and H3 are given. In terms of cm, please remember it is cm, not the SI unit. You need to convert first. And lastly, find the pressure reading in the gauge. Alright, PA. P of air actually. Okay, try first. 11:45. I'm gonna ask you. Okay, later on, while doing this, after the class, I'm going to invite you one by one through email. Okay, so after this, please send your email through WhatsApp group. Someone need to create a list of need to send the email, and then you need to add your email. So I try to take out all your email and then invite you through email. Okay, everyone. Have you figured it out? What's the final answer for the P gauge? Everyone, are you there? Aina Zafira, do you raise your hand?
Sorry.
Yes, doctor, we are here.
Okay. If you have any question, you can raise your hand as well. You can see the button there. All right. You have heart, like, you have applause, love, everything. You can use the emoticon there. Okay. Have you figured it out? What is the PA? Everyone?
Not yet.
Just follow the same thing what I did. Okay, I noticed that you are not asking me about one things in here. Supposedly, if you try to figure it out, this question, you might ask me the first step. Why this value is not given? What I just noticed. What are the things that the information not given? So you should be proactive. Why this is not given? Where is the reference value? How to consider the reference value? Okay, so it's okay. I just want to see your working solutions, everyone. So it is already the time's up. So what did you get? Which, even though you haven't complete, please let me know which part that you confused. Because the last, just now, I show you the concept only, how to apply. For this case, this is the real problem that you need to input the value. Okay, so the first time you might be difficult for you. Later on, it will be easy. So, have you figured it out? What's the final answer? Everyone?
No.
Okay, do you surrender? Give up? Okay, which part? Okay, let's see. Muhammad Nur Sad Alam, are you there? Nur Sad Alam, are you there? Saidatul Raihana Balkis, are you there? Because I just want to confirm whether you just open the link and then leave the session. Okay, because I just get a feedback from other lecturer. Some of student previous session, previous semester just open the link and then leave it there without going through the lecture. Okay, Putri Nur Farah, are you there? Okay.
Hello?
So many. Okay, you are there. Walid, Khalid, are you there? Because
Yes,
I want to double check whether you
yes,
are actually in this session or not. Okay. So,
Doctor,
yes.
you haven't shared the QR, right? Yet.
Because I have the technical issue. Can you see my screen now?
Okay.
I have the invalid credential because I don't know all the lecturer today have a same problem, cannot access to the attendance.
Okay.
Right.
Doctor,
So,
I can hear you, doctor. I have slow internet connection. That's why I can hear you later.
oh, I see. So what's your name?
Mohammed Nurshad Alam. Yes, doctor.
Okay, okay, it's okay. So have you tried to work out this example?
No, doctor.
Okay.
Give up.
Okay, please don't give up. At least try to list out the hydrostatic equation. Okay, Shafiq, are you there?
Yes, doctor.
So how?
I just got, I don't know is it correct or not. I just got the hydrostatic equation.
Okay. So let's check the answer. Let's redo step by step now. Okay, I want you to focus here. This is very important. Okay, if you follow my step, my style, I can notice that you understand when I mark your test 1 and test 2. If you use different kind of style method, I can spot out with other student. So this is very important to grasp the concept first. Okay, the first is let's start from left and going through here. We start from here and finish to here. You should make the path. All right. So for this case, please assign the reference point or the reference of elevation. So what is our reference of elevation? Let's say we use this as our reference. This is datum. Okay, everyone? Do you want to ask why I use this datum? Or you already know?
No, doctor.
Yes, I want to ask.
Okay. Why I use this datum? Because if I use this datum, I already have the value. You can see the H1 and H2 start from where? The question asks. Start from this bottom side, right?
Yes.
If you look at H3, start from where?
From there also.
From here. So do you think this is easy for me to start from here?
Yes.
If I start from here,
It's easier.
if I start from H1,
Yes.
I think it is difficult because I have to figure out this one and H3 as well because I need to plus minus. Okay?
Oh.
Okay, if I start from here, do you think okay for me?
No.
Okay, why?
Because it's hard to find between the H3 and H1 the line.
Yes, if you
It's will
set
be a problem.
your reference value, reference level from here, you don't have any connection. Where's your connection? You don't have connection with H3. You don't have connection with H1 and H2. So this is wrong. You should start from the where you have the connection, right? So from here you can see H1 and H2 and H3 have the same connection. Which connection from here? Okay, so far you guys understand?
Yes.
Yes,
All
doctor.
right. Okay, so from here, all right, the air, this is the air, okay? All right, this is the closed tank. All right, this air will exert the pressure to where location? Which direction the air will exert the pressure?
Oil, doctor.
To the oil, okay? Is it perpendicular?
Yes.
Yes, so it is perpendicular. All right, so let's start with this case first. Okay, this is P of air, and then this one, let's start with the point 1. And this one at point 2. And lastly at point 3. Okay, so far you guys understand? Point by point?
Yes.
Yes, doctor.
Okay,
Yes.
first, we start from this path. Okay, point
doctor.
A,
Kejap, eh.
from A going to 1. Which one? This is hydrostatic equation. P2 minus P1 equal to negative rho G Z2 minus Z1. Okay, which one?
P1
Doctor.
minus PF.
P1 minus P air equal to negative rho.
Of F.
Are you sure? Can you see the what we call the path? From where? From A going to 1.
Oil.
Going through oil or going to air?
Oil.
Going to oil. Can you see?
Going through oil, yeah.
So is it oil or air?
Oil.
Oil.
Oil. So gravity Z1 minus ZA. Okay, next is which one we need to consider? Do we need to consider 1 going to 2?
No, doctor.
Okay, why?
Because
Because
It's the same pressure.
Because the pressure is
same the pressure
The
is
same pressure. Point 1 and point 2, the same pressure. So just skip here. Not necessary. So you skip, you cross to point 2. Okay, point 2 going to point 3. So 2 minus 3, 3 minus 2. Which one?
P3 minus P2.
3 minus P2.
P3 minus P2 equal to negative rho of what?
H
Hg, mercury, Z3 minus Z2. So, and then equate them together plus. So, P1 and P2. Can you see P2 the same level with P1? It is actually equal to P1, the same. So, I try to remove this point. P2 is actually equal to P1. Can I cancel P1 with P1?
Yes.
Yes, doctor.
Okay, I can cancel. Cancel what I left here.
P3 minus P2.
P3 minus
P3 minus PA equivalent to negative. Alright, this is rho. Okay, rho G. So, how to get rho of oil? How to get the rho of how to get the rho of oil?
From specific gravity.
Yes, what's the formula of specific gravity?
Specific gravity equals rho G.
Rho times G.
Rho times G, that is gamma.
Density of fluid over density of
free object
water.
over specific of water.
Okay, correct. Remember, Sg of fluid is equal to density of fluid over density of water. Alright. So how to get the density of fluid? The density of water must multiply with the specific gravity. So here,
Times 1000.
yes, correct. Density of fluid, whatever this is on, this is mercury, just change this term, is equal to Sg multiply with density of water. What is the density of water? It is 1000 kilogram per meter cubic. So, the density of oil. How to get the density of oil? The specific gravity of oil multiply with
1000.
1000. Why 1000? Because this is density of water, right? So just simplify here. Density of oil is 0.9. Okay, 0.9 negative 0.9 multiply with 1000 multiply with 9.81. Alright, Z1. Where is Z1? What is the value of Z1?
0.
Okay, 0. Why? Why 0?
Because it is at the reference point.
Why 0? Why Z1 is 0?
Because it is at the reference point.
Yes, because our reference here is 0. Everyone, do you get it? Do you understand why 0?
No, doctor.
Yes, doctor.
No. Lutfi,
No, doctor.
you
I
don't
don't.
understand
Yeah.
why zero?
Yes.
I don't understand.
Okay. So minus ZA. Where is A? Point A. This is point A. So what's the value of A?
Doctor, actually, I said I don't understand.
Okay.
Why zero?
Okay. Aina Zafira, can you explain why zero?
Because the starting point of the gauge calculation is from point 1 and point 2. So it's 0.
Okay. Shafiq, can you explain?
Okay, Amar.
Yes, Shafiq.
Okay, I want to ask you, where is the reference?
Sorry?
Where is the reference line? Can you tell me where's the reference line?
The reference line.
Yeah, where is it?
This one?
This
Between
one?
one and 2, right?
Yeah.
Okay, so Z1 is at point 1, right?
Z1.
Yeah, Z1
okay.
is
Yeah.
from the point 1.
Uh-huh.
Okay, so now point 1 is on the reference line, right?
Okay.
Okay, so if the if the Z1 is on point of reference, so which is on 0. Do you understand?
So if Z1, it's on the reference line.
Yeah, it's like, okay, now you imagine you want to go to okay, now you're at home, you want to go to somewhere. Now your reference is from your home. So
Okay.
if you at your home, how much kilometer have you walked?
0.
Yeah, it's just the same like that.
Okay.
Can you understand?
Okay,
Yeah.
I understand, Doctor.
Okay.
Okay. So can you see? I want to add up. Can you see this
Extra
point
mark
1?
for Shafiq.
Okay. Thank you,
For you, my
Shafiq.
friend.
Thank you,
I love
Aina.
Amma.
Okay. Can you see this point 1? It is on the same line with the reference, right? So the reference is totally 0. All right. We start from 0. Okay. Understand, everyone? So Z1 is 0. 0 minus ZA. What is the value of ZA? Where is the point A? This point, right? Okay, what's the value of ZA?
H1 plus H2.
Yes, why H1? Because our reference value from where? From H2, right?
Yeah.
So, from here, point A to this reference is actually H1 plus H2. What's the value? H1 plus H2 equal to? What's the value?
1.0668.
1.0668 meter or centimeter?
Meter.
Yes, you need to give your answer in meter. Why? Meter is SI unit. Okay, everyone, do you get it?
68, sir. Doctor.
Okay, sorry. 8 here. Okay, do you get it, everyone?
Yes, doctor.
So, is
Yes,
it
sir.
positive? Is it the positive or negative here?
Positive.
Okay, why positive?
Because it's above the reference.
Yes, above the reference is positive. Sorry. Okay, modified. Okay, next is the combination of this one. Plus, minus, minus win. Okay. Try. Okay, the density of mercury. How to get the density of mercury? The specific gravity of mercury multiply with 1000. So what's the value? Specific gravity of mercury 13.6. Multiply 1000 multiply with 9.81. All right. So Z3, where is Z3? This one. So what is the Z3?
H3.
H3. What's the value?
22.86.
0.2286 minus Z1. What is the value of Z2?
0.
0. So try to calculate here. Can you help me, everyone? I need your cooperation. Okay.
Doctor, shouldn't we cancel out P3 first because it's P-ATM?
Not necessary. Later on, I will show you. I want you to solve this one first.
Okay.
Must be negative.
21,000.
Okay, 21,000.
80.
Okay, 80. What's the unit?
Oh.
Pascal.
Yes, all the pressure, Pascal. You don't have to think Newton per meter square. Just to make it Pascal, simplify. Okay, so now you know P3 minus PA equal to negative 21,080 Pascal. So when the question asks the gauge pressure, so remember when it is the gauge pressure, so the first is the PATM, and above the PATM normal case, it is a P gauge. So when it is the P gauge, our reference value is the PATM. So this is our datum. So what do you think of PATM?
0. Can cancel it out.
Yeah, 0. So PATM equal to 0. So P3 is equal to 0, or is the P3 is a PATM?
Yes.
Yes.
Cancel out equal to 0. Finally, you will get negative. Negative with negative cancel out. You will get the gauge pressure at point A is equal to 21.08 kilo Pascal. Okay, everyone.
Ya, doktor.
Okay, sama tak jawapan? Everyone.
Sama lah.
Okay, congratulations. Siapa yang
sebab ikut doktor.
For those just follow my method, definitely whatever the question give you, you can solve. Sometimes the question give you like this. This is manometer. Okay. Can you see? Complicated, right?
Yes, doktor.
So if you just follow my style, start from left to the right, definitely you will get the correct answer. Believe me. Okay?
Doktor, I think kan macam kalau macam tadi buat soalan first, I ada problem macam kita nak set point macam doktor kan ada point 1, point 2, point 3 tu macam mana doktor
tak kisah.
Tak kisah.
If you set any point, doesn't matter. You can set point A, point B, point C. Okay? But make sure you go through the correct path. Kepada jalan yang benar. Okay?
Alright.
So from here, you start from here. If you set this is point B, right? This is point C and point D. Make sure B minus A. Okay? That is the nomination only. That is the alphabets only. If you change, doesn't matter. Your final answer will be the same. Okay? Syafiq?
Okay, doktor, faham. Thank you.
Okay. So,
excuse me, doctor?
Yes?
I didn't understand. How did you cancel the B3?
Okay, who want to respond? Volunteer, please. Please volunteer. I think I want to ask Amma. Amma, why?
I was going to say not me, please.
Okay. What?
Can I volunteer, doctor?
Okay. Sure. Can you volunteer?
Ahmed, because it's B3, it's PATM. If you can see in the pipe. Yes.
Can you see?
Yeah.
Yeah.
Yeah, it's near to B3. It's actually PATM. So normally, we make a reference number, which is a reference line. So above the reference line will be P gauges. But below it's BATM. Because BATM it's below the reference point, so it cancel out because the reference point is 0.
Oh.
Okay,
so
it's okay.
PATM is 0, that's why P3 is 0, right?
Sorry?
Okay, it's okay.
is 0.
Let me okay. Ahmad, are you asking me the question just now?
Yes, doctor.
Okay, this is okay. Why the PATM is 0? Okay, this one. Can you see the question?
Yes, doctor.
The gauge, right?
Yes.
Okay, what is the gauge?
It's the pressure inside the tank.
Okay, first you need to understand the definition of gauge. The gauge pressure is the pressure measured from the
it's the pressure difference, I think.
Okay, no. The gauge pressure is the the gauge pressure is the pressure measured from the atmospheric pressure. Okay? You try to Google, you try to find any textbook, the definition is the same. The gauge pressure is the pressure measured from the atmospheric pressure. Remember that. Okay. This is our pressure. Okay. The first, our nature surrounded with the atmospheric pressure. You must know that. Okay. The first atmospheric pressure, P ATM. Above or extra of the pressure extra, or we call additional pressure, is actually on top of PATM. This is called P
gauge.
P gauge. Remember, the P gauge is the pressure.
It's the pressure above the ATM.
Not above. It's the pressure measured from
above the ATM, right?
From the PATM. So where's the PATM? This is PATM. So when it is measured as a reference value PATM, that means we set this PATM as our reference
line.
Or reference line. Remember, once we set this as a reference, it is Z equal to
0.
So once we set this one as a reference point, the PATM automatically equal to 0 because the reference is actually 0. We start from 0. Okay, Ahmad?
Okay, doctor.
So that is why P3 is the P3 here. This is P3 at point 3 here, exposed to the atmospheric pressure. So P3 is actually
B atmospheric.
Atmospheric. So once we know it is a gauge pressure, so automatically PATM equal to
0.
Can we cancel this one equal to 0?
Yes, doctor. Thank you.
So what? Okay. Do you understand clearly?
Yes,
why
doctor.
it is equal to 0? Okay, everyone. Do you have any question?
No, doctor.
Okay. So I think that's all for today's session. Alright, I want to give you 2 tasks, very important. After this, I'm going to upload the assignment. The first assignment that cover week 1 and week 2. Alright, so I'm going to give you the duration of assignments. Alright, please do it. Please revise the lecture note, recording lecture note, week 1 until week 2. And then, for the e-learning part, I would like to create one forum. All right. In your section, the first step, I'm going to create the forum first, and I would like all of you to send or to post your question. All right. You need to post at least 3 questions, and you yourself that post your question need to answer at least 6 questions from your friend. All right. So that means for section example section 01, okay, first I create the forum. You need to post 3 questions pertaining to lecture note of week 1 and week 2. Week 2, for example, what is the hydrostatic equation? And second one, what is the barometer? And the third one, what is the manometer? Okay, and then some of your friend gonna answer your question. Okay, you yourself cannot answer back. Okay, but you yourself need to answer your friend question. Okay, first the rule is 3-6. You post 3 questions and you answer at least 6 questions from your friend. Do you get it?
Doctor, I have a question.
Okay.
What if we have the same question with our friends? Like,
Okay. So the rule, you cannot have the same question with your friend. So first come, first serve.
first come, first serve lah. Alright.
Okay. So
Doctor,
if you
you have to answer verbally or like write
comment.
comment.
Just verbal, just write your answer, because I want to record your status that you already answer or you already post your question and answer. Okay, everyone.
Okay, doctor.
Okay, first wait for me to create the forum first, because I still cannot access section 7 and 8. Okay.
Just inform us.
Okay, I will inform you. Sure, no problem. Okay. So
Doctor, when will
yes.
be the due date?
Okay, the due date. Okay. For the assignment, the due date will be about 3 days. Okay, it's very simple. Because my style, I will be like this. Week 1, I will be alternately. Week 1, quiz. Week 2, assignment. Week 1, quiz. Week 2, week 4. The next week will be the assignment. Okay, so alternately. So quiz, assignment, quiz, assignment. Okay, everyone.
Sure, doctor.
Alright.
Okay.
But doctor, for section 2, we did not have a quiz last week because we just joined.
Okay, never mind. I will figure it out. Okay, because I need to prepare different sets of questions for the quiz.
Okay.
Okay, thank you for notifying me. I think that's all for today's session. Okay, let me end my recording.